In today's world, we enjoy the convenience of computers, internet, smartphones, and many electronic devices. All these devices can hardly function without logic gates. So, what is a logic gate? A logic gate is an electronic device with a Boolean function. Now, let me bring you through a history of logic gates. The very first logic gates were mechanically made, and the most famous analytical engine by Charles Babbage were based on these logic gates. The first modern electronic gate was invented by Nobel Prize winner in physics Walter Boole. Subsequently, Claude E. Shannon introduced Boolean algebra in logic gates analysis, which has become the foundation in current digital logic gate research. Currently, research in logic gates is based on molecular logic gates, where logic operations are carried out in molecular level. Now that we have gone through the history segment, it's time for a practical demonstration of logic gates in one of the most commonly seen systems in our life, the traffic light systems. Firstly, we define our situation as a traffic junction with cars labeled A, B, C, and D both in the north-south and east-west directions, and pedestrian crossings labeled E, F, G, and H. We will then use binary inputs and outputs of 0 and 1. When there's a car or pedestrian, we will denote this as input 1. Conversely, when there's no car or no pedestrian, this will be denoted by input 0. So, we'll let the green traffic light be denoted by output 1. Subsequently, we'll let the red traffic light be denoted by output 0. We then constructed a truth table in Microsoft Excel containing all the inputs and outputs. We then derived the Boolean equation from our truth table by using the sum of products method. So these are our final Boolean equations. Based on these Boolean equations, we constructed circuits for the north-south traffic light, east-west traffic light, and the E, F, G, and H pedestrian crossings. So let's test our circuit with some inputs, shall we? We shall consider a test case where there are cars in both the north-south and east-west directions, and where there are pedestrians at E and H. So we'll consider the east-west traffic light output, and these are the initial inputs for this output. Now, please watch as you see how the inputs add up to the final output. Since the final output is 0, this translates into a red traffic light. This shows that our circuit is working well, as there are pedestrians waiting to cross H, and therefore the EW traffic light must be red. Thank you so much for watching our video.
Created using Powtoon.